Oh yeah, and we have the equations as well, so...
Do you want to...
Do you know what? I think maybe we'll just do the practical problems and then leave the equations and the graphs for the tutorial tomorrow then. So we'll just do practical problems then. Okay, are we nearly finished with the second one there? Nathan?
Forget the equations, forget the graphs.
No, I'll spend time tomorrow in the tutorial on equations and graphs. We're just going to have a look at the sine cosine rules today as practice.
So there's some equations with cosine, sine.
Yeah, we'll do examples tomorrow in the tutorial of those two lessons. Let's just zoom in a bit. Okay, that should be enough time to do the first one that you had to try for me. So let's have a look at the answer now for that one. In this question, we had the sun here and then the earth at two different positions. So this might be, for example, like summer solstice and winter solstice. It is the two different times of the year. By the way, this actually is a real example of how people measure how far away objects are. So what happens is, this could be like summer and this could be winter here, and here's the sun here, and it's observed that, let's see, something is observed and the distance away it is, but of course it could be, I don't know, something like here. This is seen over here in the night sky, and this angle is easy to measure, 70 degrees. And then 6 months later, in winter time, the angle is measured again where it appears in the night sky, and this angle is 80 degrees. Yeah. So when you look at this, you realize this problem is a lot like the one I did last time, wasn't it? So we can fill in the information that we know. If this is 80, then this here is 100. Yeah. If this is 100 and this is 70, this here is 10. And then if I draw a line straight down here, this distance here, I can get it by using what rule? If I call it x. Oh, and also we know that this is 300 billion meters. The radius is 150, so the total length is 300. And I'll just write bm for the moment for billion meters. Yeah. Right, so what rule can I use to find the x? The sine rule, so I can say x over sine 70 equals 300 billion meters over sine what? 10. This over sine 10. So I can use my calculator and I'll get 300 divided by sine 10. Billion has 9 zeros.
309 zeros.
Yeah, that's it, times sine 70. So here I get the x is 1623 billion meters. That's for the x. Now if I want this here, I have the x and I want the opposite, and this is right angle. So what rule can I use here? I can say that sine 80 equals h over x. So then h equals x sine 80. So I still have the answer on my calculator for x. I'll multiply it by sine 80.
So,
Yeah,
what is that?
that was winter.
Oh, I thought.
No, it's not the length here. Yeah. Right. So I got 1599. So you're looking at about 1,600 billion meters, for example. Now, of course, you realize if I zoom out a bit, if the Earth is here and the object is here, this distance is really, it's just this here. So it's not actually that far away. It'll be further than this. It's really going to be like this distance here. So if you wanted to, you could work out this distance here, but that's not too difficult actually to do. I'm actually going to do this one now. I think I'm going to, my answer is going to be, this is going to be the right answer. It's not going to match the answer at the back, but I want to do it this way to make it more accurate. So now we know this distance, and do we know this distance here? No, we don't actually, do we? No, we don't. But it's not difficult to get, because do we know this distance? Yeah, it's how much?
300.
Well, 300 was the whole thing, so this is 150. Do we know this distance? Yeah, and do we know this? Yeah, so how can I get this one?
We use Pythagoras.
Use Pythagoras to get it. So let me just write that in. Square root, yes, 1623 squared plus 1600 squared, minus. So this distance here is 272. So how much from here to here?
272 plus 1.
Yeah, 150 plus 272. And how much is this distance? We said 1600, 1600, isn't it? So can we get this distance? Yeah, again, Pythagoras. So we have square root 150 plus 272 squared plus 1600 squared, and the answer we get, it's actually not that much different. The answer we get is 1650. So there's not even that much of a difference anyways, but it's a little bit more accurate. But I was only expecting students to do this much. But if you continue to get it more accurate, you should have gotten this answer. Okay? But I think for an exam question, it probably would be more just like the first half I did.
So
Yeah.
x is for less accurate is 1,600.
600, yeah, 1,600. But a bit more accurate will be 1,650. Yeah. Yeah.
We can
Okay.
upload this and
This is recording, and I'll upload the other ones later.
because these are the practice calls in particular. I like to look at
No,
the
that's
slides.
okay. Yeah. Now, guys, look up. Listen. I did a question very like this one last time, where I give you the two angles 45 and 50, and the distance here is 5. So we're going to skip this one because the one I did in class is a lot like it, and we'll look at the next one. And the next one still is very similar, but it is a little different. What's happening in number 4, the pictures up the top, you're on the top of a cliff and you're looking down at an island. So there's two angles here when you look down. The two angles are, what did I say, 40 and 30. You also know the island is 1 kilometer long.
When you say he's looking at the northern tip,
Yeah, I just mean you're looking at the top and the bottom of the island. So this angle will be 30, and this angle here will be 40. Yeah, and in between is 10. And from here to here is 1 kilometer. Yeah.
where did you say he looks down at an angle of 40, so where's 40 again?
This one here. Oh, sorry. No, actually, let me draw it here. I might have it upside down. So if I said he looked down at an angle of 40, did I say anything about horizontal or vertical?
I love it, Ron.
Yeah. No, sorry, that's not it. He looks down at an angle of 40. Okay, so
With respect to the horizontal.
yeah, with respect to the horizontal. So this is the horizontal. If you look down at 40, it means the 40 degrees. I got it wrong a moment ago. It's measured from the horizontal like this, so that's 40. And then if you look down at 30 degrees, this one here is 30.
So if you look at the sun.
It's still 10 degrees in between though.
So when he's looking at the southern tip first
Yeah,
at 40.
yeah, this is the south and this is the north.
How can we know?
So the south is 40 and the north is.
Well, I don't remember what I said here. Hang on. He looks down at an angle 40. He is looking at the southern tip. Yeah, it's like this. It's like this.
So the south is 40.
Yeah, but I mean, it doesn't matter if this is called the south and the north. Yeah, this could be called Stephen's part of the island, and this could be called Admin's part of the island. It doesn't matter.
Why do I have to further you go to the island?
I want to be closer to the coast, okay? Right. Sorry, closer to the mainland. Closer to the mainland.
Okay.
To the mainland. Right. Try this one now. Again, it's very, very similar to the one that we did in the class. But you just have to be careful with the angles because you're looking at it upside down. Okay, so try this one for a couple of minutes. Sorry, do you need to draw it? Yeah. No, don't factor that in, it's not necessary.
Really, because it's coming in his line of sight.
I know, but the scale is in thousands of meters. It's not going to influence the height much. You know, it'll probably still be the same, correct the three significant figures anyways, because his height is going to be on the scale of 1 to 2 meters.
Yeah.
That's less than, like, it would have to be at least 10 meters to make an impact, you know. Okay, we nearly have this one?
No.
Not yet. You have an answer? No?
Yes, true.
Okay, we should have an answer by now. These don't take too long to do once you know all the angles. So, this angle here, how much is this angle? 30. And this one? 10, because the total is 40. So then how much is this one?
140.
This one now? 50.
What?
50. Because the total is 90 here.
Is the right angle?
Yeah. This is a right angle. Now, if that's 50 and that's 90, how much is this one?
40.
40, isn't it? Yeah.
40, yeah.
Yeah, and if this is 40, how much is this? 140. And if that's 140 and that's 10,
30.
30.
So,
Yeah.
is it okay, use that rule?
Yeah, that's fine, yeah, yeah. Now,
Sorry, how do you figure out that one's 40?
it's because the total must be 180.
Yeah, but how do you find the 40 first?
Because I know this is 90 and 50.
But how can you know in this is
Yeah.
right angle?
Huh?
The system.
How do I know what?
Uh,
Right angle here. Yeah, because this line is horizontal. This line is parallel to this line. They're horizontal. So this line here is perpendicular.
yeah, I know.
So this is 90, but then this must be 90 as well. Yeah. Okay, so we'll find this side here x. And I can say x over sine 30 equals 1 over sine 10. So then that means x is sine 30 divided by sine 10. 2.88 about, yeah. 2.879. Now if I have the x, yeah?
Are you using kilometers or meters?
Well, I'm still using kilometers, I haven't changed it yet. So this is kilometers. Yeah. And this is h. So I have sine 40 equals h over x. So h equals x sine 40. Now I still have the x on my calculator, so I'll type it times sine 40, and I get here 1.85 km, for example. Okay, good. Yeah. Okay, can I switch back to the worksheet now, yeah? Can you see how a lot of these, in one way, are quite similar, some of them are? Of all the types of practical problems, they like this one the most in the exam, the two different angles and the distance between them. Okay, so let's have a look at the next one here.
That name's Alberini.
Oh my goodness, this is a real person, and he's from Saudi or something, I don't remember. What do you mean?
Saudi.
Saudi.
Is that a real name?
That's a real name. I didn't make this guy up.
He's Saudi Arabian, isn't that?
No, I don't know if he's Saudi actually. Does anyone recognize this
You
name?
don't care if it's Saudi or not. Why we must care?
Wait, I mean, he's from Persia. He's
Persia, yeah.
Iranian.
Okie dokie, do you recognize him?
Bayroni.
Sarah, you know him?
You don't know him?
He's an
But he's like
Yeah.
your version of Newton, you
Yeah.
know?
I think he's even better than this.
Well, he was certainly before Newton, you know.
It's okay, we can.
Yeah. Anyways, doesn't matter. You don't care, I know. Right, so this one here, what happens here is he's trying to estimate he's trying to estimate the radius of the Earth. So here's the diagram here. He's trying to figure out what the OR and the OR is. Now, I just want you to appreciate how much you can actually do with a little bit of trigonometry, okay? He climbs to the top of a mountain and he knows the height of the mountain. Now, how might he find out the height of the mountain? Well, we've seen a problem like this before, haven't we? Yeah. Haven't we seen this before? Remember last time I did how to find the height of a building? Yeah, sorry. You remember last time I did how to find the height of a building? So, all you need to find the height of a mountain is some way to measure a small distance. So obviously he doesn't use meters, but we'll just say meters. So maybe he measured out here 1 meter. He stands here, he looks at the top of the mountain, and then he calculates the angle. He looks at the top of the mountain, he gets the angle. This is enough information to know the height of the mountain. True? We did this one like this. So if we go back to the diagram here, when we look at this problem, he climbs to the top of the mountain. Does he know the height of the mountain? He does. And then he stands on the top of the mountain and he looks to the horizon. So if you're, imagine the line of the horizon when you look off into the distance. So obviously he has to measure down a little bit to point to the horizon line. So that angle there, can you see it, alpha? That's how much he has to point down to measure the angle, is alpha here. Okay? So the two things he knows, the height of the mountain and the alpha. From only these two pieces of information, he's actually able to calculate the radius of the Earth.
You can do this in ESF.
You can do it yourself. Yeah. All you need is a meter stick, and a way to measure angles, and then that's it. Yes. I want you to try and find a formula for the radius, and the two pieces of information you know is the h and the alpha. So in your final answer, what I'm looking for is something like radius equals, and then you have a formula with only the height and the alpha in it, because these are the two things he knows. Yes? Do you understand?
So don't actually solve.
No. I just want you to know, if you knew the height of the mountain and the alpha, what would be the radius of the Earth? Okay? So try this one for a minute or two. Come on, man, try this one.
Yeah. Ruler.
Now I give you a little hint in the diagram. I tell you that here the line of his sight makes a right angle with the radius here. So you know that this is 90, and you know that this length here is r, and this length here is r plus h. So if you wanted to, you could use Pythagoras to get this one. Also, because this is alpha, you can know what this angle is here. Yeah, and if you know this angle and you know this angle, then you can also know this angle. So if you draw this, you should be able to get it. I'll give you one more minute here. Okay, let's have a look here now. No? Okay, one more minute. Okay, let's have a look here. So, here is the Earth here, and we have a line here.
We can't see.
Oh yeah, sorry. We have a line here, and then we'll just draw one straight down here, and then this one is here, and this one is 90, and then actually let me draw that again in a bit. Okay, so we'll go straight up here, and then straight down here, and then straight across here, and this one is 90. Now, I said earlier this angle here is alpha, so this angle here, 90 minus alpha, so this one will be 90 minus 90 minus 90 minus alpha, so altogether it's, no, this angle. Hang on, look, I guess it's alpha, because look, this one here is 90 minus alpha, so this one here is 180 minus 90 minus 90 minus alpha. Yeah, so it ends up with just alpha. Yeah, so this is alpha here. This side is R plus H, and this side is R. Now, we could use Pythagoras to find this side, but we kind of want to avoid that. So what should I use here, sine, cos, or tan? I should use cos.
Yeah,
If I don't want this side, if I want just to use this and this, I should use cos.
Yeah.
So cos alpha equals R over R plus H. So R plus H cos alpha equals R. So R cos alpha plus H cos alpha equals R. So R cos alpha minus R equals minus H cos alpha. What's in common here? R. So R 1 minus cos alpha equals minus H cos alpha. So I get the radius equals minus H cos alpha over 1 minus cos alpha. If I multiply the top and bottom by minus 1, I'll get H cos alpha over cos alpha minus 1 then. So, if you know what the height of the mountain is and the angle, then you can know what the radius of the Earth is. Okay, so this is the final answer here for the radius. I multiplied the top and bottom by minus 1 at the end. Okay, did you write this one down? At the end, is it? I multiplied the top and bottom by minus 1.
Why?
I didn't want the minus on the top. Yeah, here? Oh, I wrote this backwards, did I? Thank you. So, when I take it out here, this is R cos alpha minus 1 equals minus H cos alpha. R equals minus H cos alpha over cos alpha minus 1. And now when I multiply the top and bottom by minus 1, H cos alpha over 1 minus alpha. And what did I have a minute ago? Cos alpha minus 1. So just switch them at the end then. Okay, write this one down and we'll have a look at another example. Yeah, we'll have a look at 6 next. Where's my zoom in button? Yeah.
Another way.
Did you get the right answer?
No, I don't know, I'm not sure.
Yes, no. Using sign you can get it. But it looks like your or. Where's your or though?
The R?
Yeah.
No, I put the whole together. The R and H together. I don't.
Oh, you used the sine rule.
Yeah.
Interesting. That should also work, but I don't see where the or went. You know what I mean? Like it's not in the formula.
Oh.
I don't know how. Oh, you cancel.
Oh, yeah, sorry. So, we know that the 90 minus 8 is the first one, right?
Yeah.
And then the second one is 880 minus 90 minus
90 minus alpha.
Then
Hey, listen now. Listen. So, let's have a look at the next one now. Abdullah. Okay. Let's have a look at the next one now. Next one. Okay. Guys, listen. I'm just going to wait until Nathan stops talking.
It's not okay. We want to focus on this.
Shush.
Thank you. Now, let's have a look at number 6 here. So, we have ship A is 40 kilometers east of ship B. So, I'll switch in between the two graphs here. So, I said ship A is 40 kilometers east of ship B. So far we have it like this. And this is 40 kilometers. And then I tell you, ship B, however, is heading northeast, and ship A is not moving. So in a moment, I'll draw that in. So ship B is heading northeast. So that means ship B is moving along this way. And because it's northeast, we actually know what the angle is. What's the angle here? For northeast? 45, yeah. So, my question is, how far has ship B travelled when A and B are closest to each other? So, what's going to happen here is B is going to move along, and then at some point the B will be nearest to A. What's special about this point when it's nearest? Yeah, that the distance here is a perpendicular distance. And I asked, how far has ship B travelled? So what I actually want to know is this distance here. Okay, so this is what I want you to find. So I'll give you a minute or two to try and find this X.
That's 45.
Huh?
How do you know?
Northeast is, by definition, at 45 degrees. Okay, you should be finished this part. Because this is a right angle triangle, we can use sine, cos and tan. Because this is the hypotenuse and this is the adjacent and this is the angle, I should use cos. I can say cos 45 equals x over 40. So then x will equal 40 cos 45, which is 28.3 kilometers. That's the first part done. Okay. Can I go on to the next part now? Yep. So the next part. Guys, please. We know that ship B can call ship A if they are 40 kilometers apart or less. Ship B at some point will be 40 kilometers from ship A, after some time has passed, they are no longer 40 kilometres apart. How far has ship B travelled while the two ships are in radio range? So at the very beginning, are they in radio contact?
Yes.
They are, because at the very beginning, how far away are they? 40. And then as the ship moves along, it's only getting closer to A, isn't it? So when it's here, how far away is it?
You can see.
Oh, sorry, thank you. It's 40 away at the beginning, and as it moves across, it's only getting closer. So how far away is it here? 28. Now what happens as it moves past this point? It's getting further away. Okay, so, yeah, my question is, how far has ship B travelled while the two ships are in radio range? Now, I think I might have made this a little bit too easy. Yeah, so I'm going to change this because that's stupidly easy. I know it is.
Easy for you. Not for us.
No. But I think there's a mistake here. Hang on.
Yeah.
Oh, I'm sorry. So sorry. I misread it. Be quiet, please. Thank you. Please. So, I've misread the question. To save time, I'll just do the whole question now, okay? But I'd like you to pay attention closely. So, my mistake when I misread it was when I read it, I just read ship A. Can you see that? Yeah. I just read ship A is 40 kilometres east of ship B, and I skipped over this part, and 30 kilometres north. So I didn't draw that in the picture. So let's draw that in. Ship A is 40 kilometres to the east. So this distance here is 40 kilometres and 30 kilometres to the north, like this. It's here it should have been. Now, at what angle does B head at? Well, it's still going at 45 degrees, so it's going along here at 45. And the closest is still at what angle? 90. What's this angle here? 45. No. So we are looking now for the distance from here to here still. It's going to be, no, the 50 will be which distance? This one will be 50 from Pythagoras. Yeah? So we're trying to get the x here. Now what we could do is we could get this angle. If I know this angle, then how can I know this angle? Well, the total is 45. So if I know this, I can minus and get this. I'll just do tan inverse 30 over 40 will give me this angle. So tan inverse 30 over 40 is 36.87. So this angle here is 8.13. If I know this angle and I know this side, what can I use to get the x? Sine, cos, or tan?
Cos.
I can say cos 8.13 equals adjacent over hypotenuse, x over 50. So then x equals 49.5 km. So the answer to the first part should be 49.5 km. Now, the second part. Can I switch back to the question? Yes? The second part? So the situation is still the same. We know that they can radio each other when they're 40 kilometers apart. So, at the beginning, how far away are A and B? 50. So can A communicate with B? No. So what's going to happen is, as it moves along, it will get closer and closer. Yes? And how far away does it need to be if it wants to contact A? I said in the question 40, didn't I? Yeah. Now, this distance here, do we know it? No. But I can easily work it out because I have this length and I have the other length. So using Pythagoras, 50 squared minus 49.5 squared. So this distance here is only 7.05. So when B makes it to here, can it talk to A? Yeah, because it's less than 40. Can it still talk to A afterwards? Yeah, but only for a distance of 40. So at some point out here, it's going to become too far away. Can you see that? And can it talk to A as it gets closer to this point? Yeah. It starts off at 50, but at some point it will be at 40 distance away. Close enough. Now if you look at this triangle, what type of triangle is this if this side is 40 and this side is 40? It's isosceles, and we know the height of it, don't we? So let me just draw that triangle again out here. This is 40, this is 40, and this side here is about 7.05. And I want to know how big this is. Well, I could use something like Pythagoras. Because if I get this answer and then multiply it by 2. So square root 40 squared minus 7.5 squared is 39.3. What do I need to do to this answer? Multiplied by 2, and so the total distance is 78.6 kilometers. So from here all the way over to here, that's a distance of 78.6. And it can still talk to A because it's always less than 40 for that part of the journey. It's difficult. I know it's very difficult, but this one, I did see it in an exam one year. Yes, it was a big question, yeah.
And how do you students go?
Oh, they did okay.
So they were able to answer it? They were
Wait, listen. I know some of these questions are difficult, and you have to read them carefully, and you have to really think about all the angles and sides, but they're important for the exam. Now, the good news is, these are section B questions, which means you have the time to do it. So, like, if this was an exam question, you would have about 10 minutes to do this question. And I think 10 minutes is enough time to do this. I think so. Yeah, what we're going to do now, there's still 3 more questions left. So, 4 more questions left. So, what I'll do tomorrow in the tutorial, after you try these at home, is I'll do them in the class. And then after I do those 4 questions, we'll have a look at the equations and some graphs then. Do you want me to bring the projector to the tutorial to record it? Yeah? Okay, alright. Okay.
Did you upload only one?
I will upload them, yes.
Tomorrow I can't come because I have Gen ID.